Imagine a creation born from human ambition, a vessel of steel and rivets stretching longer than 3 football fields. This was the RMS Titanic. It was more than a ship, it was a promise of a new era of travel, of luxury, of safety. People called it unsinkable. This wasn't just a marketing slogan, it was a statement of faith in our own technological prowess. It was a floating city, a testament to industrial might and a beacon of progress. The journey began with celebration. Passengers from all walks of life boarded, from the wealthiest industrialists to hopeful immigrants. For 4 days, the Titanic was a world unto itself, gliding across the placid ocean surface under a canopy of stars. The powerful engines propelled it forward, a steady heartbeat pushing this marvel of engineering toward its destination in New York. The universe, however, had other plans. On the night of April 14, 1912, the cosmos aligned in a fateful way. In the freezing waters of the North Atlantic, a colossal iceberg, a mountain of ancient ice calved from a Greenland glacier, floated silently in the darkness. The impact was described by many survivors not as a great crash, but as a subtle shudder, a slight grinding sound. It was an almost gentle touch from an unstoppable force of nature, but this gentle touch was fatal. The iceberg tore a series of gashes along the ship's starboard side, breaching 5 of its 16 watertight compartments. The unsinkable was sinking. In less than 3 hours, the magnificent Titanic slipped beneath the waves and began its long 2.5-mile descent to the ocean floor, taking more than 1,500 souls with it. For decades, the Titanic was more than a shipwreck. It was a legend, a ghost story whispered across generations. Its final resting place was a mystery, a location lost to the vast, crushing dark of the North Atlantic. Many tried to find it. They searched with sonar, with magnetometers, with hope. But the ocean is immense. Its floor a landscape of canyons and mountains far more rugged than any on land. Then, in 1985, a breakthrough. A team led by oceanographer Robert Ballard, using a revolutionary deep-sea submersible named Argo, finally pierced the veil of darkness. And then it appeared, not the grand, intact vessel of legend, but a ghostly, rusted boiler. It was the first piece of the puzzle. Soon the iconic shape of the bow emerged from the gloom, upright and majestic, like a tombstone on the ocean floor. The ghost had been found. The first explorations were breathtaking. They were our first steps into a sunken world. Remotely operated vehicles became our eyes and hands. They sent back images that were both haunting and beautiful. We saw the grand staircase, now a gaping void. We saw pairs of leather shoes lying side by side on the seabed. These early studies gave us our first true understanding of the wreck site, mapping the 2 main sections and the vast debris field that lay between them. They studied the wreck's condition, noting the rusticles, icicle-like formations of rust created by metal-eating bacteria that draped the hull like a shroud. They learned how the ship broke apart, not in one piece as long believed, but splitting as it sank. Every photograph, every piece of sonar data, was a page in a new chapter of the Titanic's story, one written by the relentless forces of the deep ocean. As the 100th anniversary of the sinking approached in 2012, the Titanic called to us once more. This was no ordinary anniversary. A century is a powerful span of time. For scientists, this was a unique opportunity. It was a chance to conduct a before and after study on a grand scale. They had the detailed maps and photographs from the initial discoveries. Now they could return to the exact same spots, nearly 3 decades later, to see what 100 years at the bottom of the ocean truly looks like. The mission was driven by a new sense of urgency. The Titanic was not a timeless monument. It was an artifact in a dynamic, changing environment. The very same forces that created the rusticles were also consuming the ship. Scientists predicted that the wreck was deteriorating rapidly. Parts of the deck were collapsing. The iconic crow's nest had vanished. Some estimated that within another few decades the ship might collapse into a formless pile of rust on the seafloor. The Centennial expedition was, in a very real sense, a race against time. A mission to document the ship in unprecedented detail before it was lost to us forever. This journey was also about honoring the past by looking to the future. The Titanic is more than just a historical event. It's a benchmark. It's a laboratory for deep-sea biology, for geology, for metallurgy. What happens to steel under immense pressure and cold? What strange forms of life can thrive in total darkness, feeding on a man-made structure? The 100th anniversary provided the perfect moment to deploy the latest technology, to push the boundaries of what we could learn from this unique underwater classroom. It was about using the memory of the Titanic to advance our understanding of our own planet's most mysterious realm. So they went back. A team of experts from different fields, oceanographers, archaeologists, engineers, and microbiologists, came together for this singular purpose. Their goal was not to salvage artifacts, but to preserve the wreck in a new way, through data. They wanted to create a perfect, three-dimensional digital model of the entire wreck site, a virtual Titanic that could be studied by anyone, anywhere for generations to come. This was a mission to raise the Titanic not from the water, but into the light of scientific knowledge. To venture 2.5 miles beneath the ocean's surface is to enter another world, a world of crushing pressure, absolute darkness, and freezing temperatures. You can't just send a person down in a diving suit. You need to send our robotic avatars, our extensions of human curiosity. For the Centennial expedition, scientists brought a new generation of explorers. These were not the clumsy robots of the past. These were sleek, intelligent machines designed to navigate the treacherous, decaying structure of the wreck with incredible precision and grace. They were our emissaries to the deep. These robots were equipped with cutting-edge imaging technology. They carried high-definition cameras that could capture video with a clarity never before seen at these depths. But the real game-changer was the sonar mapping. They used powerful side-scan and multi-beam sonar systems. Think of it like this. The robots sent out pulses of sound like a bat's cry in the night. These sound waves bounced off the wreck and the surrounding seafloor. By measuring the time it took for the echoes to return, the computers on board could build an incredibly detailed, three-dimensional map of every single feature, down to the smallest rivet. The process was methodical, almost like a cosmic ballet. The robotic submersibles swam in precise, overlapping patterns over the entire wreck site, a grid covering several square miles. They were like tireless scribes, patiently recording every detail of the ship and the debris field. This wasn't just about taking a few pictures of the bow, it was about capturing everything. Every twisted piece of metal, every crater left by the stern's impact, every single object scattered across the seabed. It was the most ambitious underwater archaeological survey ever attempted, creating a single, cohesive image from hundreds of thousands of individual snapshots and sonar readings. The result of all this technology was staggering. For the first time, we could see the entire Titanic wreck site as a whole. The data was stitched together to create what scientists called a virtual hangar, allowing them to fly through a perfect digital recreation of the site. They could zoom in on a teacup or zoom out to see the bow and stern sections lying nearly half a mile apart. This wasn't just a map, it was a digital preservation. It captured the Titanic in a specific moment in time, 100 years after its sinking, creating an invaluable baseline for all future study. Armed with this new digital model, scientists could finally see the full extent of the ship's decay. The Titanic was visibly collapsing. The comparison between the images from the 1980s and the new data from 2012 was, well, stark. Entire sections of the deck had caved in. The officers' quarters, where Captain Smith once stood, were rapidly deteriorating, their roofs sagging under the immense pressure and the slow, relentless work of gravity. The ship was being consumed by the ocean. It was a powerful, humbling reminder that even our grandest creations are temporary, subject to the same laws of entropy that govern the entire universe. The most striking change was the proliferation of the rusticles. These were not just passive rust formations. Microbiologists discovered they are complex ecosystems, communities of bacteria and fungi working together. These organisms literally eat the ship's iron, converting the solid steel into a delicate, flaky oxide. They are the primary agents of the ship's decomposition. The rusticles drape the ship like brown, icy stalactites, some growing many feet long. They are a living shroud, slowly and methodically returning the Titanic's 50,000 tons of steel back to the basic elements from which it came. The new, comprehensive map also revealed surprising details about the sinking itself. By analyzing the debris field with forensic precision, scientists could reconstruct the ship's final moments in greater detail. They found evidence suggesting the stern section rotated like a helicopter blade as it fell, rather than plunging straight down. The wreckage on the seafloor told a story. They could see how the ship hit the bottom, the bow section plowing into the mud with such force that it buried itself nearly 60 feet deep. But amid the decay, there were moments of incredible preservation. In areas shielded from ocean currents and anoxic mud, artifacts remained in startlingly good condition. A leather satchel, a coat, a single boot. These objects, protected from the metal-eating microbes, offered a poignant connection to the human lives lost. The digital models allowed archaeologists to excavate these sites virtually, without disturbing them. They could analyze the placement of objects and gain insights into the ship's final chaotic moments, all while leaving this hallowed ground untouched. The ship was a ruin, yes, but a ruin full of stories. The Titanic is not just a dead ship, it is a thriving ecosystem. In the utter darkness of the abyss, where sunlight has never reached, life has colonized this artificial reef. The Centennial expedition was not just about history, it was also a deep-sea biological survey. Scientists were amazed by the diversity of life they found. The wreck is an oasis in the vast, muddy expanse of the abyssal plain. It provides a hard surface for creatures to attach to, and its slow decay provides a source of chemical energy for a unique food web that exists completely independent of the sun. The most dominant life forms are the bacteria and fungi that make up the rusticles, but they are just the foundation. Grazing on these microbial mats are other, more complex organisms. Scientists identified new species of sea anemones, crabs and shrimp that have adapted to this specific environment. They observed brittle stars with their long, spindly arms clinging to the railings, and strange, pale fish swimming through the ghostly corridors of the wreck. The ship has become an island of life, a testament to nature's incredible ability to adapt and flourish in even the most extreme and unexpected places. One of the expedition's most fascinating discoveries was a species of Halomonas bacteria, Halomonas titanicae, which was previously unknown to science. This is the microbe at the heart of the rusticles, the primary engine of the ship's decay. Understanding this bacterium is crucial. It not only explains what is happening to the Titanic, but it also has implications for the modern world. How do we protect modern offshore structures like oil rigs and pipelines from similar forms of microbial corrosion? The Titanic, in its decay, is teaching us vital lessons in microbiology and materials science. This deep-sea ecosystem raises profound questions. How did these creatures find the wreck? How have they evolved over the past century to live on it? The Titanic provides a perfect time-stamped experiment. We know exactly when this artificial habitat appeared. By studying the life on the wreck, scientists can learn about the rates of colonization and evolution in the deep sea, one of the least understood biomes on our planet. The ship, a symbol of a human tragedy, has been given a second life as a cradle for new and undiscovered forms of life, a vibrant biological community in the eternal night of the abyss. The detailed forensic mapping of the wreck site did more than just document decay. It settled long-standing historical debates. For decades, survivors' accounts of the ship's final moments were contradictory. Some swore the ship sank in one piece, while others insisted it broke apart. The discovery of the wreck in two main pieces in 1985 confirmed the breakup, but the Centennial expedition's data allowed for a much more precise reconstruction of this catastrophic event. It was like having a perfect frozen crime scene to investigate a century later. By analyzing the precise layout of the two main sections and the debris field between them, engineers and naval architects could create new, more accurate computer simulations of the breakup. The new evidence suggested that the bow section, filled with water, pulled the stern up to a steep angle, but perhaps not as high as depicted in popular films. The stress on the ship's keel became too great and it began to tear apart near the middle. The bow detached and planed away, while the stern settled back into the water before sinking. This detailed analysis provided a definitive, science-based narrative of the ship's final moments. The comprehensive map of the debris field itself was a historical treasure map. It showed not just large pieces of the hull, but thousands of smaller objects. These artifacts told the human story of the sinking. A pile of dishes from a galley, a stack of floor tiles from the smoking room, a child's toy. The location of these items helped historians understand how the ship's contents were ejected as it sank. It provided a chilling minute-by-minute timeline of the destruction. The debris field wasn't just a junkyard, it was a carefully preserved pattern of the disaster, waiting to be read by the right technology. This new level of detail also helped to debunk myths and conspiracy theories. The detailed scans showed no evidence of a massive gash, as was once theorized. Instead, they confirmed that the iceberg impact caused a series of smaller punctures and buckled the hull plates along a 300-foot stretch, allowing water to flood in. The science was clear and irrefutable, captured in the digital model. The Centennial expedition provided the final word on many of the physical questions that had surrounded the disaster for 100 years, replacing speculation with hard, empirical data. It gave the victims and their descendants a more accurate, factual account of the tragedy. The importance of the 2012 expedition goes far beyond the Titanic itself. The mission was a proving ground for technologies that are now transforming all of deep-sea exploration. The ability to create high-resolution three-dimensional maps of the seafloor has applications we are only just beginning to imagine. We can use this technology to explore hydrothermal vents, discover new mineral deposits, map underwater volcanoes, and lay telecommunication cables with greater precision and safety. The Titanic, in essence, helped us develop a better GPS for the bottom of the ocean. The study of the wreck has become a cornerstone of a new scientific field: underwater archaeology. Preserving a historical site in a hostile environment like the deep sea presents unique challenges. The Titanic mission pioneered a new philosophy of preservation through digitalization. Instead of removing artifacts, which can accelerate the decay of the site and raises ethical questions, we can create a perfect virtual copy. This allows for non-invasive study and ensures that the site is accessible to future generations of scientists and historians, even after the physical wreck has completely disappeared. Furthermore, the biological discoveries on the Titanic have profound implications for our search for life elsewhere in the universe. The discovery of Halomonas titanici and other extremophiles, organisms that thrive in extreme environments, shows us how tenacious life can be. It proves that life can exist without sunlight, feeding on chemical reactions. This gives us hope that we might find similar life forms in the subsurface oceans of moons like Europa or Enceladus. The Titanic is a small, terrestrial example of how life might arise and persist in the dark, cold corners of our cosmos. The Titanic also serves as a long-term experiment in materials science. How do man-made materials hold up over a century in the deep ocean? The data gathered from the wreck helps engineers design more durable ships, submersibles, and offshore structures. By understanding the rate of corrosion and the forces at play on the Titanic's hull, we can build better and safer technologies for our own time. The legacy of the Titanic, therefore, is not just one of tragedy, but also one of innovation and knowledge, echoing through science and engineering a century later. The story of the Titanic is a timeless human epic. It's a story of ambition and failure, of technology and nature, of life and death. But the story did not end on that icy night in 1912. It continues today, in the silent darkness of the abyss. The Centennial expedition showed us that the wreck is not a static monument, but a dynamic place of change, decay, and rebirth. It teaches us a lesson in humility. It reminds us that no matter how great our creations, they are ultimately subject to the powerful, patient forces of the natural world. Exploring the Titanic is part of a much larger journey, the exploration of our own planet. Over 70% of the Earth is covered by water, and we have mapped the surface of Mars and the Moon in greater detail than we have mapped our own ocean floor. The abyss is the last great frontier on Earth. The technologies developed to study the Titanic are now our keys to unlocking the secrets of this vast hidden world. Every time we send a robot into the deep, we are pushing the boundaries of human knowledge, venturing into a realm that is as alien and mysterious as outer space. The Titanic's greatest lesson, perhaps, is about our own curiosity. It is the same impulse that drove us to build the ship in the first place that now drives us to explore its remains. It is the desire to see what is over the horizon, to understand what lies in the darkness, to piece together the puzzles of the past. This drive is at the very core of what makes us human. It is what fuels all science, all art, all exploration. The ship of dreams may have sunk, but the dream of discovery, the dream of understanding our universe and our place within it, lives on. As we continue to gaze into the cosmos, searching for answers among the stars, the story of the Titanic reminds us of the wonders and mysteries that still lie waiting in the depths of our own world. The journey to the bottom of the sea is a journey into our own history, and a voyage toward our future. The Titanic is more than a shipwreck. It is a destination, a laboratory, and a timeless symbol of the endless, awe-inspiring, and sometimes terrifying universe we all inhabit. The exploration of our world and our cosmos is the greatest adventure of all.